Hello guys, this is Adam Camp. Welcome to my channel Physics for Fun. In this video, I am going to teach you the necessary elements to work with the 2D polar coordinate system and will show you how to find the area of circle using this idea. Now, in this video, I am going to cover some of the contents which I am going to describe you here. That the first, I am going to tell you why do we need the coordinate system, and therefore I am going to describe you what are the coordinate systems that we are going to have, and we are going to look for, because this video is constrained, I am going to describe only the polar coordinate system, so I am going to derive the polar coordinate system, and then I'm going to derive the position vector in the polar coordinate system, as well as I'm going to show you how to find the area of circle using the polar coordinate system. Now, let me first describe you why do we need the polar coordinate system. In a simple word, to locate the object's position, we need a coordinate system. Example, suppose you are in Earth and you want to track your position, so what you are going to use is GPS. Now GPS is going to give you some coordinates, some degrees in north and some degrees in south. These coordinates are simply longitude and the latitude. In this physical world, nothing is absolute. It means that you cannot say this object is big, thin or large or etc. You need to compare from what? Okay, you are suppose 5 meter distance. Now 5 meter is what? 5 meter doesn't exist in a absoluteness. You have to put some kind of a reference that 5 meter from this to this one, or 5 meter from the north pole, or 5 meter from the south pole. So the absoluteness of any kind of quantity is irrelevant in the physical system. That's why we need to introduce some kind of a coordinate system, or we are saying it as a frames. Okay, so the frames is going to give you the framework to enable you to measure some kind of a quantities under you can predict what is the acceleration, velocities or positions of any kind of thing. So that is why we need the coordinate system. Now there are several kinds of coordinate system. Mainly it is four. The coordinate system which is having, suppose in 3 dimensions, you are obviously you can move in any direction, just like right, left, up, down, top, bottom. Okay, now what happens is that based on this thing, one is called Cartesian coordinate system, and in proceeding with this there is another system which is called the polar coordinate system. In Cartesian system, you have three parameters like x, y, and z. And in polar coordinate system, there are two coordinates, that is r and theta. Now, in three-dimensional world, there are two kinds of symmetry that exist. One symmetry is called cylindrical symmetry, and another is called spherical symmetry. The most symmetric object in three-dimensional is called sphere. But we can also study the cylindrical system. So in cylindrical system there are three quantities like radius and angle and the height, that is my z component. And in spherical symmetry we are going to have the r's, theta and phi, that is the radius component and the longitude component and the latitude component. So I'm going to show you how this polar coordinate system is there. Now you can see that this is the polar coordinate system. You have the three circles right here, 1 2 3. Now if you want to move from one circle to another circle and proceeding like this, now what happens is that your this distance increases. Now you have in a circle there is two kind of quantities. Now one is called r and one is called theta. Okay, so what happens is that now if r is increases, means you are going from here to here and again from here to here. Okay, so your r is changing. So from here, 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 your r is keeps on changing. Now what happens is that if I am going to this direction, okay, so this direction, what happens is that for this guy and this guy and this guy, the thing that is changing is called theta. So now what happens is that your theta is constantly changing as you go from these points to these points. So what happens is that your r and theta, now in the coordinate system that is called Cartesian coordinate system, that is my x, y and z, the three parameters are x, y, z. Now in 2D polar coordinate system it boils down to two things, that is my r and theta. Like in Cartesian coordinate system in 2D it is only having x, y, y, z or zx. Now I am going to have to write the position vector in the polar coordinate system. Now first we have to understand that what are the elements. The elements are r and theta. Now how we can relate with this kind of coordinate system. Okay, so based on this kind of system we are going to derive the polar coordinate system of this. So suppose if I have to write the polar position for this Cartesian system, how I'm going to write? Suppose this is a point. Now the position vector can be given like this. So what I'm going to do is that make some perpendicular on x, then y, and then again g. So the r vector can be written as my x, this is magnitude, and the unit vector, again the magnitude y hat and z hat. Now what you can surprise that what is my x hat? X hat is nothing but unit vector. It gives you the direction. Suppose you are in x, so what is the increasing direction of x? Now this is my increasing direction of x. So this is my x hat. Well, if you have some kind of a vector, suppose this is my vector a, so the increasing direction of any kind of vector is going to give you a unit vector. And you know the definition of vector, the vector is having this magnitude as well as direction. So if you have any kind of vector, the increasing direction of that vector is going to give you the unit vector. Well, if you have understood this one, so the position vector in a three coordinate system is going to give you this thing. Well, now I have to figure out what would be my polar coordinate system then. To understand the polar coordinate system, what I am going to do is like this. Well, since it is in 2D system, so let's assume that this is my 2D system. Now from this you can see that this is my r vector, and suppose there is some kind of an element here. So what happens is that the unit vector is going to give me like this. Now I have already told you that if my theta is here, now you can see me, now you can see here that how your theta is going to vary. So this theta is going to vary like this. So if I am going again this direction, so what happens is that now this guy is moving from here to here. So what happens is that your radius is not increases or decreases, it is not changing, but theta is changing. So the change in theta, this is going to give me the theta hat. Okay, well, now so what is going to happen is that this is my r hat. So the perpendicular component, since these two guys are perpendicular to each other, so the perpendicular from this, since it is my theta, so theta hat is going to the increasing direction of theta, and these guys is going to give you, if you are dot product with these guys, it will going to always give you the 0 dot product. It means that r hat, I can write it as r hat magnitude of r, magnitude of this guy into cos theta. If it is 0, then this is my 1, because magnitude of any unit vector is going to give you 1. Now cos theta is 0. For what angle the theta is going to give you 0? Is my 90 of degrees. So theta is 90 degree. Well, in Cartesian system you can remember that x dot y is going to give you 0. It means x hat dot y hat is going to give me 0. It means that they are mutually perpendicular to each other. Now, same goes for polar coordinate system. Now how I'm going to derive this thing? So if you are having this r vector, what is the projection of r vector onto x? This is the any kind of vector. Now you can use the cosine term. Suppose there is a cos, if you want to take the cos of theta is going to give you the base over hypotenuse. So the cos theta is going to give you, base is my x, suppose it is in x direction, and hypotenuse is my r vector. So it is going to give you r, because I am taking only, I am interested in magnitude, so I am taking just magnitude. Okay, so x is going to give me r cos of theta. Similarly, for this guy, what I am going to use is sine theta. Sine theta is perpendicular over hypotenuse. So sine theta is going to give me, and this guy is parallel to y, is parallel to y axis. So let's take another magnitude, that is y over r. R is my hypotenuse, so y is equal to r of sine theta. Now what I am going to write it as, r vector is, in terms of this guy, I can write it as r cos theta x hat, r sine theta y hat. Now what is going to happen? So this is the position in terms of now angle. So here you can see that there is two terms, that is r and theta. So now this Cartesian system has converted in terms of a polar coordinate system. Okay, now there is not only involvement in x hat and y hat, there is also involvement in r and theta. So now it has turned in r and theta. Now you can write it as, now what would be the r hat? So I have to figure out what is my r hat and theta hat. One way of getting the r hat is simply the r, the vector over this magnitude, because r is common, and r vector over r, since I have already described you, I think here, well, no, suppose if I am having the vector a is my magnitude and the a hat, so what is going to give me the a hat is nothing but a vector, sorry, is my a vector over this magnitude. Okay, so this is going to give me the a hat. So another way is writing this thing is, suppose if I am taking this a vector over a, what happens, since a is magnitude, so this will be again gone, and we are left with just nothing but a hat. So there are two ways we can give this thing. So now if I am taking this thing by over dr, so this is going to give me cosine of theta x hat and sine of theta y hat. Differentiation of r vector with respect to r hat is going to give me nothing but r hat. So this is my r hat vector. Okay, now proceeding with this thing, what happens to theta hat? How is it going to give me the theta hat? So if I am having this r hat, now you can see that here these guys are my r hat. R hat is in this direction. Now if I have to give me this thing, suppose theta hat, now theta hat is in this direction, so what happens is that this is my r hat. Now the change in r hat with respect to angle is going to give me the theta hat, because the r hat can be this vector. I want to see the change in this vector with respect to angle. So the if angle is the angle can be changed like this, so this vector is going to give me change similar to this one, and now the vector is going to produce like this. So this vector is nothing but parallel to this theta hat, is going to give me this theta hat. So if I am going to write the theta hat, I have to write it like this: r hat over theta is going to give me, now derivative with respect to theta is sine theta x hat plus cos theta y hat. So this is the amazing result that you are going to get by using these guys. Okay, now you can easily verify from here that r dot theta is going to give you 0. You don't have to do anything, just multiply these guys, and you are good enough to see that this is proved. So I can safely say that these radial and angular components are perpendicular to each other. Now one more thing, you can see that x hat and y hat can be written it as, suppose I am taking is equation 1 and equation 2. Now this equation we can figure out what is my x hat and y hat in terms of r hat. So if you want to see, so suppose I want to figure out x hat, so what I'm going to do is that multiply 1 by cos theta and multiply 2 by sine theta. So what happens is that if you multiply these guys, this becomes cos theta and sine theta, and now from here if I'm going to multiply with this thing sine theta, this will become cos theta multiplied by sine theta. Now these guys are same, now this negative this thing, what happens is that this will cancel out. Since I have multiplied this thing by cos theta, it will become cos square theta, and similarly this will become sin square theta. Now I have subtracted, so this will become positive sign. Now cos square theta plus sin square theta is going to give me 1. So I am just left with x hat. So I can simply write it as, you can see the simple algebra, because this is kind of a class 10 algebra. So cos theta with the r hat minus of sin theta, theta hat is going to give you the x hat. Now you can see that you have written this component, these are the Cartesian system, and you have written this everything in terms of what? In terms of simply r and theta. Now it has completely changed in the polar form. Okay, now similarly the same rule goes for this guy, for y hat. So what happens to y hat? Now if I multiply this by sine and this by cos, this will guy cancel out, and this will become cos sine square theta cos square theta. Now these are same, so cos square theta plus sine square theta is going to give me 1. So I don't have to do anything, just what happens is that sine theta r hat plus cos theta hat is going to give me the x hat and y hat. Now you can easily check that x hat dot y hat is going to will give you the 0. So in this way I have figured out what is my polar coordinate system. Okay, so we have derived easily that what is my r hat and theta and what is my r vector in terms of radius and these guys. Now proceeding with this thing, now one more thing, if I'm going to describe you a very crucial step. Suppose you have some kind of a vector here. Okay, now what happens this vector is that suppose you fix the length of this vector. Now how it going to give you change? This is my coordinate system. I am assuming that now your vector is fixed in length. What happens now? The movement, the freedom it is having left, that it only can move like this. Okay, so what you can analyze is that the length is not changing, but what is changing is orientation. So from here the theta is increasing like this, so it will completely form a circle. So if you are having some kind of a vector whose radius is fixed, the 1 degree of freedom it is having left, that is my orientation, change in orientation. That's why you are always see that the circle is having the radius is fixed. So to make circle, the all the radius is just moving. That's why radius having the length is fixed and it is forming a circle. So it arises you the rotation thing. Okay, the radius is fixed and the change in the only takes change in it is the orientation. Now, well, we have seen here that in Cartesian form, suppose in 2D system, r vector is my x hat, y hat. So what happens to the differential form? That if I really want to see the change in a very minute distance, suppose from here to here I want to change, that is my dr, then how I can take account? So dr is nothing but the simple change, and it means infinitesimal change in x hat and infinitesimal change in y, that is my y hat. So the dr vector can be given by like this. Well, what happens the position in this polar coordinate system, then how one can give you the change in, how one can give you the rare position in the polar coordinate system. Okay, now we have seen that, well, in Cartesian I have described you these guys. Okay, now what I am going to do is that since we know x is equal to r cos theta, now from here you can see that this is my x, so this is my r cos theta. Now y is my r sin theta. We have already analyzed this thing. So r cos theta, what happens if you differentiate these guys? So if I want to differentiate, the first I am going to differentiate with respect to r and theta, because it is a function of r and theta. So first it will differentiate with respect to dr, and then the cos theta will be cos theta. A simple rule of the chain rule of derivative. Now again with respect to theta, so it will going to give me minus of sin theta of d theta. Similarly it goes for y is equal to r sin of theta. Again simple rule apply, dr sin theta plus r cos theta and again d theta. Now I have these components. Well, now I am putting these guys in equation third. Okay, so let me just write this equation third. Now what happens is that dr vector is, I am going to write, so first I have to write here these guys, dr cos theta minus r sin theta d theta, and this is my x hat, and dy is nothing but dr sin theta r cos theta d theta, and this is my y hat. Now what I am going to do is that plug these guys x hat and y hat in these things. So what I am going to do is again write these guys here. Now x hat is going to give me, what is my x hat? Cos theta r hat minus sin theta hat plus now these guys. Now multiply with that r hat sine theta plus cos theta theta hat. Yeah, obviously it is correct. Now just simply multiply it, and what is going to give you this multiplication? Now let me see that dr cos theta. So I am first writing this r hat, and it is going to give me cos square theta. Now this negative and this thing theta hat cos theta sine theta. Now these guys again r hat, okay, r cos theta d theta with negative negative positive r sine square theta d theta, that is my theta hat. Now similarly these guys, what happens is that r hat sine square theta, I may make mistake, but be precaution with this thing, this multiplication cos theta dr, and now it is done for this guy r cos theta d theta sine theta r hat, and with this thing cos square theta d theta, now theta hat. Now you can see that there are some of the quantities which are going to give you nothing, just like theta hat here, sine theta cos theta, now dr cancel out. Similarly these guys will again cancel out. Now here, well, now I'm going to left with this thing r hat, this thing. So r hat dr common, cos square theta and sine square theta is going to give me r hat dr, and now it is over. And similarly I am just left with this thing, these guys. So these guys is going to contribute nothing but r d theta theta hat. Now you have a very amazing result that says that in polar coordinate system, now you can see that the everything has been converted in nothing but only r and dr. So before I have derived the whole thing in terms of x hat and y hat, the basis was, or unit vectors was, x hat and y hat. Now I have converted each and everything in terms of polar one. So it was a semi classical, so semi picture, but now it is complete picture of the coordinate system that involves r hat and theta hat. Okay, so this is the position of any point in a polar coordinate system. Okay, so similarly you can find it that area vector can be given as that this one, sorry, it is not with there. Now dr, r and d theta.